For millions of years, humans have been amazed by the twinkling stars in the night sky. Ancient civilizations described stars and planets in various ways. With the help of science and advanced technology today, we have learned many things about the universe that were once unknown. We now know the number of stars in our Milky Way galaxy and the potential lifespan of each star. We understand how planets orbit and how the universe expands. However, despite all our knowledge and ongoing research, there are still many mysteries about the vast expanse of the universe that remain unsolved. Considering this, a question arises. If we were to develop an advanced civilization with the ability to create spaceships that travel at the speed of light, could we ever traverse the universe? Is there a border in the universe that even an advanced civilization could never cross, no matter how long it exists? Despite the rapid progress of science and technology, how far can human civilization actually reach in the universe? To find answers to these questions and uncover the hidden truths of the universe, let's embark on a journey together. Our Earth, a part of the solar system, orbits around the Sun. Earth, with a diameter of 12,742 kilometers, marks the starting point for our exploration of the universe. Within about 100 trillion kilometers, our solar system is so vast that we cannot currently cross it using any spacecraft. The closest star, Proxima Centauri, is 4.3 light-years away from us. Even if we were to travel at the speed of light, which is about 300,000 kilometers per second, it would take us at least 4 years and 4 months to reach there. The farthest spacecraft sent so far, Voyager 2, would take around 73,000 years to reach there. If we were to build a spacecraft that travels at a speed of 400 kilometers per second, it would still take us about 3,000 years to reach there. Despite the impressive speed of light, Proxima Centauri is still a staggering distance of 42 million core kilometers away from us. Our Milky Way galaxy, part of the local group, contains between 100 to 400 billion stars. With a span of approximately 200,000 light-years, our galaxy is immense. Stars began forming in our galaxy around 13.5 billion years ago, and many stars are now approaching the end of their life cycles. We are in a phase where the birth of new stars has slowed down significantly. In our Milky Way, only about 3 new stars are born each year. This slow pace of star formation is a challenge for our exploration. The universe is expanding rapidly, and it presents one of the greatest challenges to our exploration efforts. The observable universe is comprised of countless galaxies, and even the nearest ones are incredibly far away. Our local group forms a supercluster, which is part of an even larger structure. These structures continue to form clusters and superclusters, creating an intricate web of galaxies. With over 1 trillion galaxies in the observable universe, the vastness is overwhelming. While we may attempt to explore regions connected by gravity, there are limits to what we can achieve. Considering all these factors, we can only hope to explore a fraction, perhaps only 6%, of the observable universe. Bound by the limitations of the speed of light and the vast distances between galaxies, we will never be able to fully explore and interact with the entirety of the universe. The boundaries set by gravity will forever limit our reach, and we will never be able to explore more than a tiny portion of the universe's true expanse. The universe is vast, and its mysteries are profound, challenging us to expand our understanding and explore the unknown. After the Big Bang, the matter that was condensed into a tiny point starts expanding in many trillion times smaller portions than seconds. The matter, once compacted in a small size, has now spread across many trillion kilometers, and everything is continuously expanding at an incredibly fast pace. This is the era of inflation. At this time, the matter that was condensed at the one point of the Big Bang has expanded so much that clouds of heavy and dense matter have formed in various parts of the universe, while in some places there is light and low-density matter. Now, regions with heavier matter experience the effects of gravity, causing them to contract, leading to the gradual formation of galaxies, As galaxies form, they are connected by gravitational bonds, either directly or indirectly. Our Milky Way galaxy, along with Andromeda and other dwarf galaxies, has been formed by gravity in a similar process, known as the local group. Beyond this group, anything present is moving away from us due to the influence of our gravity, constantly expanding. Just like the local group, many galaxy groups are moving away from us, making it increasingly difficult to reach them in the future. However, the challenge is also that we do not know how fast our universe is expanding and why. Scientists attribute this expansion to dark energy, which counteracts gravity and pushes things apart. Due to this mysterious energy, space is continuously expanding, and its expansion rate is increasing over time. This expansion is happening faster than the speed of light. Scientists suggest that a boundary, a cosmic border, has formed in the universe beyond which we cannot interact or observe. Just like a black hole's event horizon, once something crosses this boundary, we can never observe it again. Similarly, our cosmic horizon has been created, and it is shrinking continuously. As time progresses, our border is contracting, and galaxies are moving farther away from us. About 94% of galaxies have already crossed this horizon, implying that even after an eternity, we will never be able to interact with civilizations residing in those galaxies. However, a question arises. If we cannot interact with these galaxies, how do scientists study them? The answer lies in light. In this universe, there is a limit to the speed of light. Because light travels at approximately 300,000 kilometers per second, we can only see objects when their light reaches us. The galaxies we see today are actually much farther away than they appear. For instance, if a galaxy is 12 billion light-years away, the light we see from it left there 12 billion years ago. Thus, the image we see of that galaxy is from the past. However, as time progresses, these galaxies move even farther away, and their light will never reach us. We can only capture old images through telescopes. This indicates that our universe is constantly expanding and objects are moving away from us at speeds faster than light, making it impossible for us to reach them. Even with technology like spacecraft, we cannot surpass the speed of light. To explore beyond our cosmic boundary, we need to find a way to travel faster than light. Presently, we can only explore within our observable universe, which contains billions of galaxies, and its expansion limit is currently around 18 billion light-years. In billions of years, the Milky Way and Andromeda galaxies will collide with each other and create a new galaxy named Milkomeda, with trillions of stars. However, even within this galaxy, we will remain confined. Over time, due to the effects of dark energy, our local group will also break apart, and galaxies will drift away. Eventually, even galaxies in our local group will be too far to reach, and we will be left wandering the universe. Currently, about 60,000 stars per second are moving away from us beyond our cosmic boundary. The images we see through telescopes depict objects that are already unimaginably distant. As of now, we are discussing the observable universe, which was formed about 14 billion years ago. Many galaxies have turned into supermassive black holes and are so far away that they are beyond our observable universe. We do not know the exact rate of our universe's expansion, but we do know it exceeds the speed of light. The physical limitations imposed by the speed of light prevent us from ever reaching the remaining parts of the universe. Therefore, to break our cosmic boundaries, we need to find a way to surpass the speed of light, which will allow us to reach places that light cannot. Currently, in this video, that's all. Here, you've come to know about the concept of the space boundary and cosmic horizon, beyond which neither human civilization can venture, nor can we ever interact with the galaxies and other objects present beyond it. Due to the expansion of the universe and the constraints of our physical limits, this boundary has been formed, which tells us how vast our universe truly is. I hope you enjoyed my video and have learned a lot. So, go ahead, leave a comment, ask questions, and share the video. Along with that, For more knowledge of science and to understand closely, subscribe to Universe Tour and bookmark it. Subscribe to the channel and also press the bell icon. I'll be back next week with another exciting science video.